Welcome back to HowToHub, the home for surprising deep dives into how the world around us really works. Today we're going behind the scenes of something so ordinary yet so powerful that your life depends on it every single day. It's in your car, around you in every building, beneath your feet in bridges and railways, and even in the tiny utensils in your kitchen. We're talking about steel, the material that shapes civilization itself. Even if the object you're holding right now isn't made of steel, chances are steel was still involved in making it. From pipelines that carry water and gas to skyscrapers that kiss the sky, from the washing machine in your home to the smallest paper clip on your desk, without steel, almost none of it would exist. And today, we'll explore one big question that pulls it all together. How do we actually make steel from raw rock inside the earth? It's because the deeper you do the process, the more fascinating it gets, especially when we uncover the fiery transformations inside furnaces hotter than lava. And if you're curious about the hidden forces that build our lives, make sure you're subscribed to HowToHub because this video is just one of many eye-openers we have lined up. Steel begins its journey as iron ore, dug from massive mines in places like Australia, the Americas, and Scandinavia. The rock itself doesn't look like much. It's heavy, rough, and bound tightly with oxygen that stops it from being directly useful. To unlock the metal within, it's carefully crushed, blended, and combined with coke and limestone. Coke is by and without it into a pure, carbon-rich fuel that burns hot enough to power furnaces on an industrial scale. Limestone's role might sound unimpressive, but it's the hidden helper. It binds to impurities during heating, making sure the resulting metal is clean enough to turn into steel. All of these raw ingredients are fed into an enormous structure called a blast furnace. If you've never seen one, imagine a tower as tall as a 20-story building, glowing with unimaginable heat from the inside. At the bottom of the furnace, jets of superheated air blast in with such force that the entire structure roars with energy. Inside, the temperature climbs to over 2,000 degrees Celsius, hot enough to melt rock, hot enough to turn iron ore into a shimmering pool of molten metal. From the base, workers tap out this molten iron, known as hot metal. On the surface floats slag, the trapped impurities, which are skimmed away and recycled for road building or cement. Even the byproducts of steelmaking find new uses. But here's the twist. The hot metal at this point still isn't steel. It's too brittle, packed with carbon and other elements that make it crack instead of bend. To turn this fiery liquid into something strong yet flexible, it needs refining. This is where the blast furnace hands its creation over to another dramatic process, basic oxygen steelmaking. In this stage, hundreds of tons of molten iron pour into a huge vessel lined to withstand incredible heat. Scrap steel is added too, not only recycling valuable material but also helping regulate temperatures inside. Then comes the moment of truth. A long lance lowers into the molten pool, blasting out pure oxygen at such insane speed it creates many explosions on the surface. In that moment, the carbon inside the iron burns away, boiling off as gas. Other impurities meet their fiery end too, chemically captured and pulled into the slag. In less than half an hour, the carbon content drops from dangerously high to exactly where steel needs it to be. What emerges is no longer fragile iron, but a strong, ready-to-shape steel, glowing with possibility. There's also another path to steelmaking that surprises you, the electric arc furnace. Here, you don't start with fresh ore at all, you start with scrap. Old cars, demolished buildings, and used machinery, all of it is melted and reborn. Giant graphite electrodes lower into a furnace full of scrap, and with a powerful pulse of electricity, an arc jumps between them. The glow is so intense it makes the inside of the furnace feel like a tiny sun. In less than an hour, that scrap is molten once again, impurities captured in slag, and a new batch of steel is born. This method is becoming more and more important because it is, at its heart, recycling on a massive, global scale. In fact, nearly half of the steel produced around the world today comes from recycled material. After the metal is refined, it moves to what's known as secondary steel. Here, technicians fine-tune the chemistry, removing unwanted gases, evening out temperatures, and mixing in small amounts of other alloys to give the steel the exact personality it needs. Want it corrosion-resistant? Stronger under tension? Lighter without losing strength? That character gets set right here, shaping the steel for its future life. Now comes the question, how do you go from liquid steel to solid shapes that can actually be used? That's where continuous casting takes over. The molten steel pours into mold systems cooled by water, forming long strands with solid outer shells while the inside hardens as they travel through curved rollers. Those endless glowing ribbons of steel are cut into manageable lengths and leave the plant as slabs, billets, or blooms, raw forms that are ready to be shaped further. To actually turn those shapes into parts for trains or cars. In the huddling stage, slabs are reheated and passed repeatedly through rollers, which squeeze and stretch them into thinner, longer, or wider forms. Every pass transforms the glowing orange slabs more and more, while modern computer systems measure every millisecond of the process to ensure precision down to the tiniest fraction. For products requiring clean surfaces and extremely thin material, cold rolling follows. You've probably seen the results as the shiny sheet metal on home appliances or the ultra-thin steel that eventually gets coated with tin for food cans. Then there are tubes. Steel tubes are made in two ways, either by rolling and welding sheets into cylinders, or by piercing solid billets and stretching them into hollow tubes without seams. Both methods create strong, reliable structures that serve as oil pipelines, scaffolding, drills, bicycle frames, you name it. Steel tubes quietly power entire industries. By now, if you're still watching, and I know you are, you've walked through an incredible transformation that starts with dusty rock underfoot and ends with the shining backbone of modern civilization. That alone shows why steel matters so much. It isn't just another material. It's the silent force behind nearly everything around us. From the tallest skyscrapers to the smallest household item, steel holds it all together, often without us noticing. And even better, it's endlessly recyclable. Year after year, hundreds of millions of tons of it come back into the cycle, shaped again and again into the world's next wave of progress. Next time you cross or open a can of food, remember there's a story of fire, chemistry, and human ingenuity inside that piece of steel. And that story begins with the Earth itself. Another deep dive on HowToHub, where we explain the hidden processes shaping your everyday life. If this video helped you see steel in a whole new light, smash that like button and tell us in the comments what surprised you most: the furnace hotter than volcanoes, the recycling on a massive scale, or maybe the way slag waste becomes useful again. And if you want more amazing breakdowns of how the things you take for granted are really made, don't forget to subscribe to HowToHub. That way, you'll never miss the next story about the material world that builds your world.